Hello and welcome to our first Black Belt track session today. Our presenters are Israel Vega and Stephen Follis. Israel works as a principal program manager at Microsoft. His favorite piece of software is the spell checker because you only have to spell it wrong enough before it gets corrected. His favorite languages are ASP and C#. Stephen works as a solution architect at Docker. He loves working on Windows and Azure. Stephen and Israel are loving their time at Barcelona and currently scheming on how to smuggle cured meats and wine back home. Give it up for them.
Thank you so much.
Thank you. Hi, everyone. Good morning. Thank you for being with us today to talk about Windows containers and how we handle different kinds of identity and authentication inside of those Windows containers. So today we're going to talk about a couple different things. First is kind of a refresher and primer around Active Directory, how domain controllers work, how different flows work with Active Directory, and get a good foundation there. Next, we'll move into how we take those principles and apply them to individual containers, how we get a Windows container to work with Active Directory. And then towards the end, if we've got some time, we'll talk what this looks like, not on a single server, but how we scale this out to a clustered environment for more real-world type environments there. So good. So with that, Israel, if you want to go ahead and get us started here on Active Directory.
All right, so Active Directory. Of course, Stephen makes the Microsoft guy talk about Active Directory, so here I am. We're going to try to level set the room very quick on, just give you some basics on terminology if you're a developer and you haven't worked with Active Directory environments or you're brand new. So at the topmost level within an Active Directory, we're going to have a forest. That forest is going to be your security boundary for most of your credentials. In a lot of large environments, you might have multiple forests. You might have a forest for the users. You might have a forest for external users, and so on. Yep. Underneath there, you're going to have a set of domains. Those domains are going to be your replication boundaries for being able to move things around a large environment. In this case here, we have an example where we've got an EU domain and a US domain. Within that domain, there is also a security boundary along with that. And we've got a set of objects inside of there. Some objects are containers. Some objects are actual objects that are in the forest. The containers are going to be, in this case, groups, organizational units, and so on. If you're familiar with LDAP, then you're probably going to be very, very much familiar with Active Directory as well. Those objects that are floating around this Active Directory domain are identified by some different attributes. Those are identified by a particular schema. That schema gets loaded into Active Directory, and then different objects are associated with that schema. Service accounts are associated with one type of schema, user accounts, and so on. Those big identifiers are the SIDs, or the security identifiers, the SAM account names, and FQDNs. FQDNs will just give you the fully qualified domain name for that particular account in the forest, in the domain, and so on. When we look at what this looks like physically, we have domain controllers within an environment. These domain controllers may play multiple functions. In these large environments, you may have a lot of domain controllers. We're going to do some centralized logging. We'll have DHCP. We might have DNS, and so on. Also in a Windows environment, we're going to have another set of servers that introduce a bunch of different roles. Some of them are SQL roles. Some of them are file servers. Some of them are MSMQs, and so on. We also have clients in that environment. Those clients are mixed. We have Windows. We could have Windows clients. We could have Android clients, Mac clients, and so on. What ties all these together within a domain is this common authentication and authorization scheme. The ones that you'll hear of the most are going to be Kerberos and NTLM. NTLM is fairly old. You'll have NTLM v1, NTLM v2. Those are fairly old, Windows 2000, 2003, and so on. The newer environments, some of the larger environments, you're going to see Kerberos. You might see a mix of these things because some customers might move their domain controllers faster than others. Some of them might keep their schemas at a lower level, so they might have a Windows 2000 or 2003 schema, but they might also have Windows Server 2016s in the environment as domain controllers, right? So you'll see a mix of these, NTLM and Kerberos. The one we're going to focus on the most is Kerberos, because what that allows us to do is provide integrated authentication for the user and the services on the back end. So let's look at the front first. When we look at integrated Windows authentication, This is going to be that single sign-on. I log on to my desktop in the morning. My desktop is joined to the domain. I'm going to get a single sign-on experience when I hit a browser within my application. On the back end here, we have a website and a file share and so on. So I don't have to sign in again. I'm able to bounce around through that environment. When I'm on a non-Windows environment, or I'm off network, or I'm not domain joined, I can still get a kind of an IWA experience, but I'm going to get prompted for a user ID and password. In this case here, I'll put in my user ID and password, and then I'll be able to authenticate, and I'll get access to those back-end services. So let's look at what that looks like from the back end. So we talked about the front end, how I get access to that application from the front. Here we have how I logged in. I could log in with a user ID and password, could log in with a Windows integrated credential. This app server on the back end, when it goes to connect to a back end resource, if it uses a user ID and a password, right? So you'll see this with SQL Auth. You'll see this if it's connecting to another type of application. That's not integrated Windows authentication. That's just using a user ID and password to get to the back end. Another way to connect, again, front end to or app server to back end server is Windows integrated. This is where you'll see, so if you're a .NET developer, it's Windows integrated equals true in your web.config. If you're connecting to a SQL Server reporting services, and so on, you'll see this. If you have other applications that integrate with Windows, you'll see this as well as Windows integrated. With applications that you're trying to migrate, some of these old ones, some of them will be using user accounts, where they'll have service accounts, right? So you'll have a service account that connects to the back end. That's what we call trusted subsystem. User authenticates to the front, and then the application authenticates to the back differently, right? They use trusted subsystem or as the app pool account for web servers. There's another scenario that gets a little more complicated where we talk about a delegation scenario, and that's where the service account is able to take that user's information, their authentication session, and actually pass that to the backend server, right? That's delegation. What does that look like? There's this concept within Kerberos called constrained and unconstrained. All we're saying here is it's constrained to a particular service, or unconstrained, which means I'm allowing it to go bounce around the environment using Kerberos. So in this case here, when we talk about constrained and unconstrained, we've got a user logging onto an app server, we've got a protected resource, but how does that app server pass that user's credentials all the way to the back? So these scenarios would be like file shares, or if you're connecting to a SQL server, let's say it's an HR database, and you want to do row-level security within a database, right? So in this case here, we're going to introduce an account that's going to be trusted for delegation. And what that account is going to allow you to do is it's going to specify within the domain that this particular account is trusted to pass that user's information from the front to the back without prompting that user for a user ID and password. So it's going to go ahead and create a session for that user, take that session, pass it to the back. So what does that look like logically? It's going to take that user credential from here. That app server is then going to turn around and hop that credential over to that other resource, right? In some scenarios, you can see this called the double hop scenario. In more complicated scenarios, this will be possibly 3, 4, and 5 scenarios where you're logging onto the front end is bouncing it maybe to a WCF, maybe it's bouncing it to a web API. That web API is then bouncing it somewhere else, and so on. But it's taking that credential all the way through. That's what we talk about when we say constrained delegation or Kerberos all the way down the line.
Good, thank you, Israel. So how do these concepts apply within the context of a Windows container? How can we take some of these concepts that are running today in a virtual machine type environment and move them into Windows containers? So first off, you'll see that we run Windows containers running on top of a Windows host. That host is domain joined into the forest, and we have domain resources that are also controlled by that domain controller. First off, we do not domain join every single container. Active Directory was built at a time where you added servers, you domain joined a server, it stuck around for a while, for a year, 5 years, 10 years, relatively static type workloads. AD wasn't really designed to put out 5 containers, scale them up to 20, scale them back down to 3, back up to 15. Active Directory would have a really hard time keeping up with all of that. So the pattern we use instead is that we domain join the host machine that the containers are running on top of. And so at that point, the container still can't talk to those domain resources directly. So if we try to query against that, hey, we've got a problem. And so we need a mechanism that can tie together the container, the host it's running on, the domain controller, and all those resources. And in this world, that's just something called a group managed service account, or gMSA. gMSAs are not new. They're not something that Docker invented last week. They're an object that has been a part of Active Directory for many years, dating back to at least Active Directory 2012. So they are a passwordless service account. So instead of a user ID and password, I have a user account, basically an account name, and then I designate which servers are allowed to use that account to make calls against the database or any other resource there. Because it's passwordless, the password is sitting in the forest, and Active Directory manages the generation and recreation of that password on regular intervals. So you don't have to worry about every 90 days changing your password there or accidentally getting locked out of your account. And so we're able to pass that gMSA into the container and then make those calls. At a high level, how this works, first we create a gMSA. We can do that directly in Windows Server. We do it via PowerShell. We create the account object. Next, we then install that account on the servers that we want to use that gMSA with. So a simple command to install that onto the server. At that point, we can then grant that service account permissions for various resources, for a database, for an MSMQ, to talk to LDAP, a variety of different things that we do, as we've always done with service accounts, grant those permissions. Then it comes time to generate what we call a credential spec file. What a cred spec file is a JSON doc that essentially points to that service account and provides the ID, a locator for that service account. We'll take that JSON, and then when we create a container, we pass the JSON into the container, which then allows that container to assume that identity for when it's making those calls there. So kind of at a high level, we step through each of those pieces one at a time, and after the end of this, that running container with the cred spec can make those calls against the resources. So to kind of walk through what this looks like in PowerShell, we start out setting up the domain controller. So first thing we enable is the KDS, the key distribution service. This is that mechanism inside of the DC that's generating the master key and processing things. Next, we come in and we create the gMSA. We put the groups together. Any kind of servers that we want to manage, it's a lot easier to create an Active Directory group, as Israel mentioned, and put those PCs into that group and apply permissions to the group. Heck of a lot easier when you've got lots of Windows servers you're wanting to work with. And I'm blowing through this kind of quickly. Just wanted to have these as a resource. You'll get these slides afterwards in case it helps. So good. So after we have the domain controllers and the Windows Server host nodes set up, now we create the gMSA. We pass in the exact principals that are allowed to use that password, typically that group that we've identified in the previous step. And then once we have that gMSA, it comes time to install it on each of the servers, and then we can generate a credential spec. So Microsoft puts out a PowerShell module, very easy to download and generate the JSON. We don't have to generate that from scratch. I don't really like digging around in JSON. This handles all of that for us automatically, quite convenient. So what's inside of this credential spec file? I mentioned it's some JSON. So I've got a picture to represent what's inside of there. It's really two blocks. One is some information around your domain. So information about the forest, information about the domain that you're using, NetBIOS, kind of basic domain information, location information. Secondly, we pass in the gMSA account information into that cred spec. And so we can have one gMSA. We can have multiple gMSAs. You don't have to have just one. There we go. So if I had a Windows container that was running, say, 4 or 5 Windows services, I wanted 4 different gMSAs to be used there, I can pass all those in as a credential spec file. And then at the bottom you see we've got a simple generation. When it comes time to actually running that file, we can pass this JSON into the container in 2 ways. The standard way is having this JSON file on the file system, and we point to it when we start up that container. The second way that's haven't seen it used quite as much, but as an option, is to place this JSON file in a long string inside of the Windows registry and create the container pointing at the registry. So 2 different options to get the JSON into that environment. So what's happening under the hood with this credential spec file? So we bring up a container in a variety of ways. Docker run, we can use compose, we can use stack for different services. We'll talk a little bit about what this looks like in the cube world here at the end. Pardon me. And then we also pass that credential spec file. So when we say Docker run, the client is talking to the host compute service within Windows, or HCS. HCS is an API that wraps lots of low-level pieces of the Windows kernel and allows us to create containers. But it does something a little bit different when we have a credential spec. So we pass that JSON data down to the container credential guard, which is what is responsible for talking with Active Directory, to generating and refreshing those Kerberos tickets. Credential guard is essentially a small vault, kind of secure area of the Windows kernel that's dealing with high trust scenarios with these Kerberos tickets. Secondly, we also create the container as normal with HCS, but at that point we do something a bit differently. we use something called LSAS to set the identity of that container to utilize that gMSA. So from that point forward, if I'm in that container and my application is going out to query a database or a secured resource, instead of querying as local service or network service, we're instead going over with that domain credential and being able to do that communication. So I want to take it down a little bit and explain kind of what's happening and under the hood as to how this is flowing through. So right now, I want to take a moment and kind of walk through how we generate these files and work with files in older applications. So I'm going to flip over to, I've got a Windows Server 2008 machine that's up and running. So this is running in a VM, it's domain joined. We've got a variety of apps that are running here. We've got 3 different apps all running on the same server. The one we're focused on today is this job site. We can post jobs, we can look at open jobs, and it's all talking against the database. If I open up IIS Manager, we can see from an app pool perspective that this jobs app currently is running as a service account, running as a traditional service account that's there. When the application queries the database, it uses that account. So what I'm going to do very quickly here is grab the code from this application and start moving towards containerization. So we're on a VM right now. I want to move over and pull the code out. So for that, I'm going to use something called the Docker Application Converter, which is the tool that we've been working on here at Docker to make some of this stuff quite a bit easier. And so I can say discover, I give it the file system, and then DAC is going to go out and spider through that environment. It's going to grab all the code. It detects quite a few things around the operating system. It knows about IIS, so it's looking at app pool settings, all those pieces, and then generates a manifest of what it all found. So it says, hey, we found 3 different sites. Do you want me to go actually fully containerize these? So yes, I want you to containerize those. Let's do the job site. And we are done. At that point, it spits out all the files onto the file system. It pulls that out of the environment and allows me to have that application code ready to go. So here, I've got sitting on the file system, if I go it that way, is that we've got DAC, and then it puts things into a tree. So if I come into the files that it detected, we've got the different sessions, session 1, applications, IIS. So it's built to do multiple applications, and now we have our jobs app. So inside of here, we have a Docker file, we have all the code that it pulled out, we have everything ready to roll. So to do the actual Docker build and the containerization, I would copy this file, and I'd switch over to a machine that has Docker running. We can't run Docker in a Windows Server 2008 environment, so I've got a dev box that's also up and running. This is running, I think, Windows 10 up in an Azure environment. So what I'm going to do is I will open up the local file system. If I can type today, we will paste that into this DAC folder. Now I've got the jobs here as well. I pre-copied that over so we didn't have to sit and wait on network transfer. And then I'll pop this open in Visual Studio Code and let's take a look at what's inside of there. So we generated a Docker file, pretty standard IIS ASP.NET based file. We've got a from statement. We removed the default website. We detected all the features that are available in the operating system, so we're passing those in. Because we talked to IIS, we know what that site was bound to. It's bound to port 80, so we bring that over with the expose statement, and then we initialize the website there. When we look at the web config file, as Israel mentioned a moment ago, the standard way that we enable integrated Windows authentication is in the web config file. And so in the connection string here, we can see we've got this integrated security equals true. And that's one of the joys of integrated Windows Auth. As a developer, I set a flag, I get a lot of these benefits more or less out of the box there. So this is set to use, the application is set to use the application pool identity to query against the database that's set up in this connection string. So if I open up a PowerShell window, we can very quickly do a build of this container, which is just going to take that Docker file that we had. We're going to build that. It's built and ready to go. And then we're going to start that container. So we're going to do a Docker run, kind of a traditional way of how we've done Docker run here. So I run selection. It's going to create that file. I'm going to publish port 80 that's there. And then we've set up just to grab the IP address for that container, pipe it into Chrome to save a bit of time there. And so after IIS starts up, the application will be running not in that VM context, but in a cloud environment on Docker in a Windows container. And now it's going to be trying to access that database as it starts up. And so one of the things we see is that, hey, the login has failed here. We've got a problem. So we're unable to open the connection to the database. And that's because right now we're running as just a local account inside of IIS. We haven't told it anything about a service account. So what we've done is ahead of time, we've got a gMSA that's been generated, but we now need to figure out a way to get that into the container. And so for that, we use that credential spec file. And so if I import the module, I create a credential spec, and then we'll open it up in code to see what that looks like. So these files automatically get generated and placed in the Docker folder. So Docker/credential specs is where that file will be. And you can see here, just like we showed in the slide a moment ago, a couple blocks for information around our service accounts and information about our domain. So now that we have this JSON on our file system, we can now recreate the container and pass that in, letting the application use this credential against that database. So if I flip back over to my PowerShell, we're going to delete the running container. We will recreate the new one, and then we will open that up in the browser as well. So I run selection, and you'll see this time we're passing in the -- security option flag as part of this run statement. And it's pointing to the file system and giving a name, DCEU-gMSA. That's the JSON file that we created a moment ago in that previous step. And so we're going to open this up in the browser. The application is starting up, but this time IIS is able to utilize the credential that we passed in to then go talk to a database. So if we wait for IIS to get through the cold start, now you see we have our application. We're able to talk to that database through that credential spec and can do things like logging into that exact same database and use the app as we always would. So I think we had Moby, exclamation points. Good, so we can log in. We're now logged into the app. We're talking to that database. Now we have that data flowing back and forth. So the final step we would typically do here is now I've got this working on my individual developer machine, but now it comes time I want to check it into a registry, such as Docker Trusted Registry. At that point, we can simply check in the image. And then when we want to run that in the other environments, we would just have to have that credential spec file present. So I'm going to go ahead and I push that in the Docker Trusted Registry. And now we've taken an application that was running on a virtual machine. We've moved that into a container. And then we've run that container with a credential spec so that we can talk to domain security resources. So that's the kind of the high-level pattern of how we fit together with these environments. So to kind of wind up, to kind of put everything together in kind of one screen, we have a variety of different flows that we can utilize for Windows containers. First off, we have anonymous authentication on the front or basic authentication. So it's not using a Windows account. Usually users just automatically can use the app, or they use a simple username and password. If we're wanting to that on the front end and then utilize that same method to the back end, just utilizing a username and password to the database, we don't need a gMSA at that point, and that works fine. There's no kind of specialness with the integrated Windows Auth or Kerberos being used in that environment. In the second scenario, if we're using a basic login on the front, so simple username and password, we can't go back to the database as the user with that delegation approach because we don't have a Windows account to utilize in that flow. So that's not going to work with or without a gMSA at that point. However, when we get down to these last two rows, this is where we're utilizing integrated Windows authentication on the front in two different methods. In the first one, the service account talks to the database as the service account. Give me everything this service account is allowed to retrieve. But in the second flow, this is that delegation, where the gMSA, the service account, is talking to the database, but as Stephen, but as that user that's logged in with that Windows account, and is then able to provide that information. So that's utilizing that Kerberos delegation approach, and is a bit more sophisticated, but as Israel said, gives you more options as far as row-level security for your applications. Good, so with that, we wanted to kind of walk through each of these scenarios. We put together a sample application that demonstrates kind of in code how each of these flows work kind of in the real world here. So, yep. Israel?
So before I jump over to the application, I just want to give you behind the scenes of, how do we configure this gMSA? How do we configure this particular account? So here what you can see is my domain controller. There's all my gMSAs, right? You notice we generated a bunch of them because we wanted to test, and it wasn't working. So I'm just going to select properties, and what makes the magic happen around these delegation scenarios is this property called MS allowed to delegate to. And I mentioned earlier that the application is then going to the back end. Well, when it goes to the back end, if you wanted to use Kerberos, you don't want to ask the user for a user ID and password again. In order to do delegation, you have to have this account be trusted. And then what you have to do is do constrained delegation so that it's only trusted for specific services. So in this case here, what we've trusted our account for is for the first one there is SIFS. SIFS is the file system, right? And we'll show you how to access a file server in a second. Those other ones there are LDAP. So if this particular service account needs to go talk to AD for some reason, some of those older applications actually went and accessed group information and so on, you have to provide it access, and that service is the LDAP service. For SQL, it's the MS-SQL service. So that's going to allow this particular gMSA to have access to those backend services, and Windows will know that when you want to take a credential and throw it to the other side or do a double hop, these are the scenarios and these are the services that are allowed. So that's what that gMSA looks like. Let's see what those scenarios look like. So here we have our sample app, and we're sitting in a container, right? We're accessing a container that's running in the environment. And here we have a set of scenarios. The first one there is what Stephen talked about, which is just anonymous. Very similar to the application that he migrated over. You log on as an anonymous user, you have access to everything anonymous. But when you go to the back end, the application goes as a service account, right? That's this particular one. That is very similar to this scenario, which is what's called the forms scenario, where I'm going to log on as a forms user. In this case, I'm not logging on as a Windows credential. I'm just logging on as a forms user account. So it doesn't exist on the domain. What you'll see a lot of times is like in e-commerce scenarios or in older scenarios and so on, where you have a separate database. That database controls your users. But when the application goes to the back end, as we mentioned, you know, here this app, we're going to go connect to the back end, go hit select. And here we're going to go to the back end. We're going to talk to the back end as that gMSA. Another scenario that we have is Windows scenario. So here we have the two different scenarios where I'm going to log on as a gMSA and I'm going to do delegation. So we know this is a little toggle up front here for this app. So here I'm going to go ahead and connect to SQL. I'm just entering some data to go to connect to SQL, and now I can connect to SQL. If I want to go select and connect as that user account, I'm going to select this delegation scenario, so I'll just change it so that you don't think I'm pretending. So here what I'm doing is, behind the scenes, this code is actually impersonating as that user account. My Zoom isn't working very well. All right, so here what we're doing is, in code, we're saying take the user's credential, go do what's called an S4U logon underneath the covers. You're telling Windows, hey, I want to go authenticate as this user, and I want to pass this credential to the back end. And I go ahead and pass that credential to the back end. So that's how it works for SQL. Here we have another scenario where we're going to go connect to a file share. And again, I'm in a container. Let's go ahead and connect as the gMSA to this file share. And we notice there's no data. Well, why? Well, because the gMSA doesn't have access to this file share. Only users have access to this file share. So we'll go ahead and select the user, switch to the file share. And now you can see that I'm browsing this particular file share. This file share here, I have this secure file. Here's some information that's only for me. And in our app, we're basically going and delivering that application through a handler. And here we can get access to that file. Right? So this is a container browsing a file share as a gMSA, but the credentials that are getting passed all the way down the wire is the actual user that's authenticated to that container. If we want to see what that gMSA looks like, again, this application, and it's open source, so it's on GitHub, so we can give you access to this as well. So here we can see that this application can now, this container can then talk to the domain and get access to these domain information. This user account control is something that I'll show you right now, which is what allows that delegation to work. Zoom within a zoom isn't working. So let's look at that user account control quickly. Let's go back to our service account. And if we see here, there's an attribute within AD called user account control. And what that tells Active Directory is what type of account is this? A normal user account will have a flag. Different service accounts can have different flags. In this case, what we're saying is we're providing a user account control. Let's go ahead and edit that. And it's an enum flag, right? So it's a bit mask that gets added. So in this case here, we're adding probably the upmost user account. We're adding all the enum flags to this particular account to grant it that Uber control. And that Uber control is not just is it allowed to delegate to a service, so it's not only is it allowed to delegate itself, but it's also allowed to delegate user credentials down the wire. All right, so we'll switch back to slides.
Absolutely. So as we look at moving this from an individual machine onto a cluster. And working with customers over this past year or two, there's been some lessons learned and things that we've uncovered that are kind of important for when you go out to do this. And I want to talk about, in addition to the technical pieces of how to exactly configure AD, there's some non-technical pieces as well that should be top of mind when you're working at implementing this for your applications. The first of which is that to use a group managed service account, we do require that there's at least one Active Directory domain controller, 2012 domain controller that's in the environment. You do not have to raise your entire functional level up to 2012. So if you're at 2008 or 2003, that's okay. But just by adding one server into the environment, that schema gets expanded to support group managed service account objects within the environment. So we work with a lot of folks that are still in 2008. It's usually much easier to just add one 2012 than try to say we're going to raise all the functional level. Second, as we mentioned before, group all the nodes together into an AD group that you're going to use as your worker nodes. So when we're talking about nodes, those are container hosts that are going to be running containers. Add them as a group makes life a heck of a lot easier. Thirdly is about the credential specs. So to run a container across a cluster, that container can run typically on any one of the Windows Server nodes that are available to the orchestrator. And so for that, we want to ensure that we have those credential spec files, those JSON files, available on each node where a container could potentially land. So there's a variety of ways to distribute these, from RDP sessions and copy and paste over to more group policy type approaches. And we also have an example in the back of this deck around how to use a global swarm service, where we take the JSON file, put it into a config object, and then can utilize the swarm cluster to distribute those via bind mounts to each of the nodes that are in the cluster. So a variety of ways to do it. Whichever fits best for your organization, just know that you need those JSON files on multiple machines. Fourth is around business processes there. So who is going to be responsible for creating the group managed service accounts? Who's going to add the permissions? What does the ticket process look like? How does that differ from our existing user account piece today? So there's some business processes pieces that comes when you're the infrastructure team or the dev team talking to the AD team, which is typically a different area of the organization or different people that have a bit different responsibilities. Processes are very important to iron out in the beginning because you're going to be needing at least one gMSA per application. Finally, when it comes to mapping permissions, that's all about taking the permissions that exist today as a service account or as a user account and mapping those to a gMSA. So ensuring that that new credential has the same permissions for the same databases, file shares, et cetera, so that you don't have any disruptions in application behavior there. So one other word I mentioned that we would talk about Kubernetes towards the end. So far this has been a bit more swarm-centric, and that is primarily because right now Kubernetes does not have support today for Windows Server worker nodes. It is coming very soon. So right now I believe it's expected to ship in 1.14, Q1 of next year. So at that point we'll be able to run Windows containers inside of a Kubernetes scheduler. The difference here is that Microsoft has said that when the Kubernetes support initially launches, one feature that didn't quite make it in before code freeze was support for these gMSAs. So it'll be coming later in the year. Don't have any set information today on that, but know that on day one, if you fire up Kubernetes with Windows support in Kube 1.14 in a few months, know that if you try to load a gMSA, you may have an odd experience there because they haven't quite polished at the gMSA piece. So how we're positioning it right now at Docker with customers is start today, containerize that application, because that's going to be consistent regardless of orchestrator. We'll deploy on Swarm today with gMSAs. We've had support for over 2 years for that within Swarm. And then in 6 or 8 months, if you want to transition to Kubernetes, it's a simple redeployment when the gMSA pieces are ready to go. So just wanted to give a little heads up that in the short term, we've got some considerations there. And then finally, some other kind of gotchas to mention. So right now, you'll notice that when we were doing Docker run in those PowerShell statements, we always loaded in with a -- host name. And that's because in the Server 2016 era, which most of us are still in, we needed to match the host name that the container is running as with the name of the gMSA that's running. And so if you get a mismatch there, we get very odd security errors that pop up, and it's not going to be able to resolve and talk to the directory appropriately. So we have to have that -- host name, we add the name of the file, of the account, and we're good to go. Also, gMSAs must be unique. And so there's a mapping of one gMSA to one container that's running in that environment. So if you're trying to scale out to have 10 instances of a web app, that's been a bit of a limitation in 2016 that we've got kind of a one-to-one mapping today. And then finally, there have been some bugs when it came to running Hyper-V isolation with gMSAs on Windows Server containers. So the good news here is that both Microsoft and Docker know that these have been issues. And many of these have already been fixed in Windows Server 2019. And you'll continue to see additional improvements over the next year trying to make this the best experience as possible. Because we recognize that having strong gMSA support is crucial for customers that are looking to take those legacy applications and modernize them through containers to get the advantages around portability, security, et cetera, that containers offer. So from a resources perspective, we have an entire GitHub link that's up there. It has all these slides. It has the application that Israel demoed. Feel free to pull those down, look at them, grab them. We want that to be a code resource when you're looking at what's the C# that we actually write in to actually do a lot of this setup. There's also some documentation pieces, both from Microsoft, that provides kind of an overview of how this process works. There's a deployment walkthrough that's on GitHub that Microsoft maintains, kind of step by step. Set up your domain controller, set everything up step by step. So if you want to reproduce much of what you saw today in your environment, the walkthrough is a great option. And then also there's the PowerShell module, also available on GitHub, to look and see how they're building those credential spec files. That all comes in a PSM1 file that you import into your PowerShell and then can generate that JSON. So with that, the gMSAs are a way that we are able to migrate these applications from where they are today, typically on premises in very old Windows 2008, 2003 environments, and move them into newer type of infrastructure. And one of the reasons why we're talking about it so much today, many folks that we talk to still have Windows Server 2008 in their environments, and usually have a lot of Windows Server 2008, potentially even 2003 and older. And so if you're looking for a way to take the application, to decouple that from the underlying operating system and move it into new infrastructure, the containers are a great way to make that modernization leap. However, most of those applications are going to need to utilize integrated Windows Authentication with Kerberos to be able to get the job done. gMSAs are that mechanism that we use inside of Windows containers to link those together, and are a way that you can take that application and maintain that, the operations of that app inside of a container, just as you always have inside of a virtual machine. So with that, we wanted to leave some time. We've got some additional questions we can answer.
Yep, so we have about 3 minutes left. We got some common questions that we've gathered over time. So the first one there, I think we have gotten that in the setup. Can I use Azure AD, AWS IAM, or something else? You can't use it directly. In certain scenarios, as we talked about, there are different applications that authenticate different ways. You've got the front end and you've got the back end. So when you're looking at your applications, make sure you know which one you're talking about to know which one you're actually going to migrate. Because in some cases, you may not need a gMSA because that application logs onto the back end using a user ID and password that's stored in the web.config. So if that's the case, you may not need a gMSA to actually do anything because it's not doing any Windowsy stuff, right? But if it does need to do single sign-on for that user, then you might need a gMSA to actually have that user account log on to the front end, right? So there's different scenarios there. Can I use Azure Active Directory domain services or the domain service that's available in AWS? The short answer is no, long answer is no. Managed service identities, no. In certain scenarios you can use them, but again, understand which part of the application you're talking about. That's what trips up a lot of developers and a lot of DevOps folks and a lot of users is they say, I need integrated Windows Auth, but they don't say where specifically. Is it the user logging on or is it the app logging on? So you just have to make sure you understand those two. And someone asked a question about SAML. You might be able to use SAML authentication in the front if those user accounts have a UPN on the domain. So if the user account logs in and there's a UPN claim that gets pushed, you might be able to take that UPN claim, convert that to a Windows identity, and then log on using a delegation scenario. Right? So I've got another application that I've done where I've done exactly that. You log on with Azure AD and then you access a file share. But in that case, the identities were mapped and the UPNs were the same. Right? So there is a way to do that. But it is a more complicated scenario. When you're looking at your patterns, the first one there is pretty simple. Just try to log in. If you walk into your customers and they don't really tell you or they can't really explain it, just go ahead and try to log in. If you need a Windows identity, then you're probably doing some type of single sign-on. If you're prompted, then it's probably Windows integrated as well. And then for the back end, ask for how I get access to those back end resources. Do I need DBA? Do I need additional access? And so on. Those are some other common patterns that you can see. All right, and we have about 1 minute left for questions. I think we're right before lunch, so we can stick around for a little bit.
We may be a little bit hungry, but yeah, we can.
Yeah.
Good. So with that, thank you everyone for coming today. We'll be around here up at the front and happy to chat some more. So thank you so much.
Thank you. All right, any questions? Yes, oh, 2 questions. So the question is, do we have an ETA on using token authentication? So what type of tokens, what type of database?
Yeah, SQL Server, for example.
So tokens as in like managed service identities or Azure? Oh, OpenID. No, they're not going to support that for like legacy, like SQL Server 2008 and so on. You have some type of support if you do a mapping between a token on the front and like a managed service identity within Azure for Azure SQL. But supporting additional authentication providers for SQL is probably not going to happen. And then you had a question there. I'll come back to you. Yep. Mm-hmm. Yeah, so today, so the question was, the comment on the slide was we had a one-to-one mapping between gMSA and container. How do we scale that? So today, there is no way to scale that. Right now, what you do is, let's say you have three web apps. You would create 3 separate gMSAs on each of those container hosts, create 3 cred specs, and have all 3 access the database. It's not ideal, right? So if you have an application, and to be fair, at where we are in the development and where we are in the environment, most applications, most legacy apps are single server apps, right? So you have a single server, you pin it to a node, you don't get high availability and so on, but they didn't have that before. So, you know, right now it's one-to-one. In the future, and the future as in 2019, it's supposed to be fixed, but we haven't tested it yet. And for Docker support, right?
Yeah, so 2019 improves that story substantially. So that after they released that this fall, it kind of got pulled back. We haven't had a chance to really put it through its paces. Mm-hmm. But going forward, that will be alleviated both from the Windows Server side, and also from the Docker Universal Control Plane side, and those pieces on the Docker side.
So today with build 1709, 1803, today it's one-to-one. Mm-hmm. Tomorrow, and I'll put that in big air quotes, tomorrow, with 2019, it is supposed to eliminate that limitation, but we haven't tested it.
Yep.
Yep.
Yes.
Oh, I'm sorry, you had a question here in the front. Sure. I'll come back to you. WCF, so WCF servers with Windows Authentication inside of containers, inside of Windows containers. What problems are you having with it today? So it should work with delegation, but sometimes WCF, you can do the double bindings where you do a cert and Windows. So it depends. If you have the cert, you have to inject the cert in the container as well. So it depends on what the configuration is. Were you getting errors? Is that, or you just haven't tried it?
Just curious.
Oh, sure. Yeah. No. So theoretically, it will work. Yep. Right. Because the way we set it up with delegation, like for example, with the file share. If you just need, are you using a separate user ID and password, or you're logging on as the user? Uh-huh.
Here's my container code.
Mm-hmm.
And inside the container, I wanted to authenticate external calls with Windows authentication, which is supported by WCF.
So WCF used delegation. So you'll have to have that gMSA configured for delegation. So what I showed you with the different SPNs, you'll have to add those to the gMSA and then test it that way to see if that works. If not, send Stephen an email or send me an email.
Should work, yes.
Yeah, it should just work. Yes, sir. If you have, yeah.
Part of why we're here.
Yeah, so I mean, we can, if you have time, I don't know, if everyone wants to break for lunch, they can break for lunch. Otherwise, if you have time, we can show you a few troubleshooting. Sure.
Mm-hmm. Yes. Oh. Yep. Pulling up. Yep. Did it die?
So, yeah.
That
Does yours work?
So.
Do yours. Just do the NL test
Yeah.
on yours. That's fine. Yeah, we'll do it on his.
Yeah.
You are.
Oh, I'm on now.
Oh, you're on. Sort of on. It's black. You have PowerPoint still up? Yeah. Okay. Now we're cooking.
All right, let's see.
Good. So there's a command inside of Windows that we can run called nltest. And nltest is kind of the quick kind of litmus test of are we connected with the container against the domain or not. And typically that's where you're going to find the errors on are things configured properly, are things not specifically working. And usually those error codes will give you at least a little bit to go off of. It'll say, there's an error that comes back that basically says you don't have the service principal names configured for that account. And then you know, oh, yep, by the way, I forgot to go set those SPNs for the account. We can go and do that.
Are you logged in? My jump box is not letting me.
I'm logged in if we want to switch over.
Just do the NL test.
Okay. Can you flip the view? Good. So apologies for the.
Yeah. So as Stephen mentioned, inside of the when you're on the host, or you get access to the Docker runtime that's running your container, you go ahead and get inside of your container. So you start a session inside of your container, and then there's a few commands that are very quick that'll tell you whether you're connected or not. Right? So the first command, you do a Docker inspect, and you make sure that your cred spec was actually injected into your container. That's kind of the first way to check. The second way to check is if you run this nltest/parent domain, and what that should tell you is what domain you're currently sitting on and what what domain the container thinks it's on. The other one to test would be nltest/query, and what that will tell you is if the account, the MSA, is actually allowed to authenticate. Those two tests, if you don't get those, then your gMSA is not working. Right? And there are some other tests that we can do. So if you go back to the Docker and do the test AD servers.
Oh.
Yeah. Yep. So Hot Dog 4 is the gMSA that's currently running on this box. If you do a test-AD service account, what that's going to tell you is a few things. One, is it a valid gMSA? Two, does the host have access to that password? If the host does not have access to that password, this will return false. So, yep.
The problem here is that if you're a developer like me,
Hmm?
even if you have super credentials, you have access to service, the normal developers don't have access to the host. So you can't check this. You can just say that it doesn't work.
Yep.
Then it's up to you to figure it out. But you don't know in a serverless environment which server they're running on. So you need
Yeah.
kind of weird stuff.
So that's one of the other reasons that we created that sample application, where you can plug in the gMSA account, and you'll know right away if it can't authenticate. If you get prompted a bunch of times and you can't authenticate, you'll know something's wrong. That's one. Two, if you plug in that gMSA account, it's going to return what that configuration is, right? Because that's just a normal anonymous LDAP call. If it's on the domain, the gMSA is running, but it's not configured correctly, the gMSA information will come back, right? So it'll tell you what the SID is and what the user account control is set to, and what the SPNs and all that other stuff is set up to. So you'll be able to see that as well.
If I set up an IIS server and I get the login prompt all the time,
Yeah, if you set up an IIS server and you get a login prompt, then do this.
well, what is that?
So what's happening behind the scenes is IIS is trying to set up an authenticated session between the browser and the IIS server, but the IIS server could be falling back to NTLM. And if it's falling back to NTLM, the container doesn't talk NTLM.
Why does it do that?
It's going to, because it can't log you in.
You need to
It's the same thing as putting an invalid password.
You can force that as you just use Kerberos. Okay, so they say, okay, if we switch to...
Yeah, you set it to use Kerberos, and the other thing you do is, do you have the web.config?
Of the app I did, or?
The app that we have.
Let me open that in, let me just go grab it from GitHub.
Yeah, that's fine. Just
IS
do the Docker file.
The Docker file for it?
Yeah, the Docker file.
Okay.
That works. So there's some configurations that you've got to do on the box as well. You got to make sure that Windows Auth is enabled in your IIS box. Line 43, what that allows us to do is if you're sitting on the host, you can open up IIS Manager if you're sitting on a 1709 machine. If you're sitting on an 1803 machine, and you're not within a Docker environment, if this 1803 is running by itself and you're not within a Docker swarm, then what you can do is connect to the IIS instance that's running in your container, and you log on using those credentials, right? So what we're doing there is we're creating a local user in that container, and then we're just enabling remote management, the IIS remote management tools.
Much easier to visualize how things are configured, where things are misconfigured.
Yeah.
In a GUI
Otherwise, you got to go in the container and do
PowerShell.
app command and do PowerShell and all that stuff. Right? The other thing, if we scroll down, keep scrolling. All right, so right there, set web app authentic property, right there. So set web configuration property, we set it to anonymous authentication is enabled, and then Windows, I'm sorry, line 108. We're setting that particular setting to Windows authentication, and then you scroll down a little bit. This one here, line 127, what that allows you to do is it enables a little more debugging on the container itself. So as you're trying to authenticate, and as you're trying to log in, it's logging things to the event log. What you do then is you go into your container and you pull the event logs out. And then you open them on a Windows machine that you can look at. You can also run PowerShell, get-event log on that container, so you can get the events. But it's kind of easier to just export the event logs and then read them on a Windows host. Right? That's some other troubleshooting there as well.
One of the last things that we didn't implement here, but we've been theorizing, that NL test, that little litmus check that we were looking at, there's no reason why you couldn't move that NL test / query into your container health check as defined in the Docker file. Because what we find is oftentimes the container looks like it's up, it's running, it's healthy, but it's broken the connection to the domain. And you don't always know that until you exec in and do that NL test. By moving that into the health check, you could add that as part of the command, return 0, return 1, based on if that succeeds. And you'd at least know that the container was unhealthy, there was a problem, it's unable to maintain that domain connection. It's not something that we got in here in time for that, but that would be another way to get better visibility into what's happening with the container.
Yep. So those are all different troubleshooting techniques. When you get prompted, there's a few ways to kind of know what's going on. If you're constantly getting prompted, it's probably something with the container configuration. Yeah. No, so group policies aren't going to apply to containers because they're non-domain joined resources. Not in a domain. Well, the one setting would be if the gMSA account for some reason was messed up. Because what's happening, and actually if you look at it in the box, in the container itself, actually scroll up. You can see this. Scroll up. Keep going to the app pool configurations. Scroll down. Line 55. Okay. In the container, what we did was we created an app pool, a new app pool, and we set the identity type to 0, which is local system. When that container is running as local system, it basically has access, it's basically as running as full control admin mode in the container itself. Right. But when it leaves, it uses the gMSA. If you don't set that to system or network identity, when it tries to leave the machine, it's going to leave as the default app pool, which is network service of the container, which when it leaves, it's anonymous. So it can't leave the machine. So what you do is you set it to system, which forces it to, when it leaves as the gMSA, and then you'll know, okay, it's logging on, it has access to the domain, it can leave the machine, then it's probably something downstream.
There's a lot of magic stuff.
Lots of magic stuff.
To make this happen.
Exactly.
Hello world. Yeah.
Yeah, I'll take that.
Yeah.
I'll definitely take that back. But that's one of the one of the groups I work with within engineering is the group that goes and talks to those guys. So
You should have done give us some code instead of just some random steps. I mean, the best is to give us some actual code.
Okay.
Or a boilerplate.
Okay.
This looks perfect.
So there is code. All that PowerShell in the documents is really what we use to go set up the
all
magic
we did
in
was
the
pull it
box.
together.
So that's available there for you. I agree that needs to be more publicly distributable and more official documentation format. But we can.
yeah,
We've at least
if you
done
go to
that
the
piece
repo,
today.
you should be able to. Yeah, and then this is the app. So this is the app that we're just running. There's a few things that we're going to add to it, so we'll just keep working on it. But it at least handles a bunch of those scenarios.
Yeah, so as part of that, one of the resources we have it's sitting on GitHub. If I can open the hyperlink. There we go. So there is one where Microsoft has gone through and put together a walkthrough that's very step by step. So basically it just starts out with a domain controller, and then you start from the domain controller and go all the way through deploying a container. It's, again, it doesn't handle a lot of the constrained delegation pieces, the more sophisticated flows, but at least kind of walks through run this command, next step, run that command, next step, run this command.
No, so you can do it here, or there's the quick start template. So for Azure, you can do quick start. For AWS, there's AWS templates that are already sitting out there to set up a domain controller. So the minimum you need, one domain controller, one container host. We did one dev box, just as a separate machine, and one SQL server. So that's kind of the bare minimum that allows you to do most of the scenarios. The reason we don't do it on a single machine is on a single machine, you'll get different behavior than if you're hopping across a wire. That's why kind of the recommendation is to do kind of separate machines.
You could add all these kind of steps into the PowerShell module for ISS. So you're using, when you're installing configure the websites inside it, you should have one step like just configure for the gMSA and then just add it.
Oh, the DAC one will do it. The DAC, configure the Docker application. Oh, I see what you're saying.
Yeah.
Like put something there.
Yeah, so you put something in that will do all these steps instead.
Oh,
So you can just have one liner, because the developer doesn't know this.
yeah. Well, now you do.
They don't care about ADs and
Well, now you know.
Yep.
Hopefully.
Yeah.
just have a PowerShell module that keeps working and running.
That abstracts away all the low-level individual
idea.
commands. That's a great idea. Yeah. To set all the SPNs and all the different pieces you need to get the kind of credential.
Yeah, well, you need a domain admin. You need to be a domain admin to do that. But
Yeah.
I get it.
Sure.
All right,
Also, so
any other questions?
yeah. Yes, sir.
So for self-hosted WCF,
Oh, they are? Okay.
okay, yeah, so the question is for self-hosted WCF services, will it work the same? So I just enable IIS. You enable the feature, the WCF feature, in order to do self-host. And then it should just work in that environment. You just have to enable that feature. So in the Docker command, go to the Docker file again. Scroll up. So 936, where we install web Windows Auth, you'll have to install that feature, which is the WCF self-service feature. So if you do a get-Windows feature, it'll tell you which service you actually need to enable, and you just plug it into your Docker file. Have you tried it and you had errors, or? Yeah. 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 So if you need Windows integrated auth, then it'll get a little more complicated. If you just need WCF web hosting, then you should just be able to activate the feature. We haven't tried that.
Yep.
I haven't tried WCF, so I got to add that.
Sounds good. So with that, guys, thank you so much for staying after, and thank you for all the questions and engagement. Hope it's been a good use of your time, and enjoy DockerCon. So Thank you all so much.